So now that we have our car wheel colliders set up, oh, what? Something wrong with my light here. One of the lights is way down. Let me just adjust it quickly and put it up. Okay, let's leave it like this. They don't seem to be aligned, but that's okay. So now that we have the colliders for our wheel set up, it's time to start the logic of our car driving. I'm going to create a new script called car controller. Okay, and open it up, and we will start by adding some variables to it. We'll start with colliders in audio source, and this here will be an array of wheel colliders that I'm going to call wheel colliders front, and I'm going to have the same for the rear. Okay, and we'll have the audio source for my engine sound. Okay, then we'll have some engine and physics parameters over here. Actually, I'm gonna add some headers to it, so because we're gonna have a whole bunch of stuff, and this will make it easier for me to see it in the editor. Header colliders and audio source, and same thing here, engine and physics parameters. What's wrong here? So that seems to be the problem here with my headers. Maybe I need to have a variable underneath it. So we'll start with a motor power, and then a float max rotations per minute, which is going to be 9,000, and my max steer angle, I'm going to set it for 30. Again, you can adjust these values as you see fit, as you play around with your game. The brake torque 1000, and then I'm gonna have the center of mass reference because we're gonna need it for my my physics. Then a float array of gear ratio and a float max speed. Actually, this max speed, I'm going to make it public because I'm going to need it for my UI eventually. Then another header for my brake lights. And over here, under serialized field, an array of lights, brake lights. Then I'm going to keep a couple of private variables. One of them a reference to my rigid body and the current gear I'm in. Then the rotations per minute. I will need to get the wheel friction curve for my physics again, and then serialized field, private boolean, automatic gear. Okay, I think that should be it for now. in start, I'm going to get a reference to my rigid body. And I'm going to set my gear to 1. My rigid body center of mass is going to be the center of mass variable. And my wheel force collider, I'm going to use any of my wheels because they have the same friction value. Okay, so now I will have first an update and a fixed update, and on the update I'm going to call a function called handle inputs. So I'm going to have a private void handle inputs, and I'm going to call it on update. And on handle inputs, what I'm going to do is, first of all, I'm check if I'm not pressing my brake. Input get button, and well, checking my handbrake actually, and my handbrake is going to be my spacebar. If I am not pressing my spacebar, I am check if I'm changing gears. Input get key down. I'm going to use left. Let me think here. I'm going to use the left shift and left control, but again you can change it for whatever you want. So left shift is going to increase my gear, and left control is going to decrease my gear. Left control there, and then I need to clamp it, so gear equals my left.clamp, and the value is gear between -1, which is reverse, all the way to gear ratio.length -1, which is my top gear. Now I'm going to check if I'm pressing. I'm not going to do this logic right now because I'm going to do drift in a different video, but let's keep it here ready. There's no key code space. What is the it's not get, but it's just get key down. Go get key down, key code space, and okay, so here we will do the drift in another video. So for now I'm just going to ignore this input. Then I'm going to add a input dot get key down key code R. This will reset the position of my car. Transform the position equals new vector 3, transform position X, transform position Y plus 2, transform position Z, and the transform rotation equals quaternion dot identity. Okay, cool. And now I will work on the fixed update. So here I'm handling the input, and on fixed update I'm going to handle car movement. And let's private void handle car movement. And I'm going to start by getting my input. So float steer is the input dot get axis. That is the horizontal axis. And then the acceleration is input get axis vertical. Okay, just scroll up, makes it easier to see. Then, so the steer angle is steer times, since the steer value, since the input value on the axis varies between -1 and 1, my steer angle is just going to be steer times max steer angle, and brake equals 0. It's not a flare, it's a float. Float power equals 0, and the float wheel RPM total equals 0 as well. Now, first of all, I gotta check if my acceleration is less than 0, meaning if I'm braking. So if I'm pressing S on my keyboard, if I'm actually trying to brake, I'm going to first of all define my brake as the brake torque times the unsigned value of my acceleration. And then I'm going to turn on my brake lights. Brake lights 0 dot intensity equals 1, and brake lights 1 dot intensity equals 1. If my acceleration is not less than 0, meaning if I'm not braking, then I'm going to turn off my brake lights. Okay. Now, let's check if my RPM is less than my motor, it's less than my max RPM minus 1000. I will check if I'm not in neutral, if my gear is bigger than 0, then my power is going to be my acceleration times my motor power times the gear ratio of my current gear. So here I'm defining how much power I should apply. Otherwise, I'll set my power to 0, and brake is going to be the unsigned result of my max RPM, take away the current RPMs. And if, okay, let me just check here. So if gear is bigger than, okay. So next I'm going to check if my gear is 0, if I'm on neutral, then my RPM is a lerp from my current RPM, and then my acceleration times the motor max RPM, that's max RPM, and a time delta time times 10. So I'm going to simply increase. If I'm on neutral, I'm just going to rev up my engine, increase the rotations per minute. If I'm on reverse, then my power is my acceleration times negative motor power. Okay, so once I did that, now I'm going to work on my wheel colliders. So for each wheel collider W in wheel collider front, I'm going to do that the torque is power divided by 2 for my front wheels. The steer angle is the steer angle I've calculated. The brake torque is the brake. And the wheel RPM total, I'm going to add my wheel RPM. And I'm going to do almost the same thing to the rear colliders, but the rear colliders receive full power. And we set only the RPM totals, and the brake torque is very, very small. And that's because our engine is in the back, and the brake pads are in our front wheels. So that's why we have this difference. Okay. Next, we need to define our rotations per minute, and that's going to vary depending on the gear that we are using. So if our gear is bigger than 0, our RPM is going to be a lerp from our current RPM, and then our wheel RPM total times our gear ratio of our current gear times 1.2. This in time fixed delta time times 10. If our gear is 0, if we're on neutral, then our RPM equals the lerp from our current RPM, acceleration times motor, nope, not motor, sorry, times max RPM, time dot fixed delta time times 10. And our gear is -1. If we're on reverse, then our RPM equals math lerp RPM negative wheel RPM total time times fixed, time dot fixed delta time times 10. Finally, I will define the pitch and the volume of our engine sound. Engine sound.pitch, it's going to, engine sound.pitch is going to be a lerp between 0.2F to 2F, and then that's going to be our RPM divided by our max RPM times 1.5. So the bigger this ratio is, the higher the pitch is going to be for our engine sound. And we're going to do something similar for the volume. And the volume is going to be not a lerp, but a clamp between our the clamp from our acceleration between 0.3 and 0.8 plus our RPM times 0.0001. I just want a tiny bit of that. Okay. Now we are calling, I set handle car movement to be called on fixed update. And one last piece of logic I need to do is the automatic gear. So we're going to create a void auto gear. And I'm going to check on my update if automatic gear, then I'm going to call auto gear, and auto gear is going to check our current RPM. Depending on it, it's going to change the gear. So for shift up, I'm going to check if my RPM is bigger than my motor, my max RPM minus 1,000. And I need to also check if my gear, if I'm not on the top gear, so my gear ratio dot length minus 1. If that's the case, then I do a gear plus plus. Otherwise, if my RPM is less than my max RPM take away 5,000 and my gear is bigger than 1, if I'm on my first gear, I don't want to automatically go to neutral. If I'm in neutral, I don't want to automatically go to reverse. So in that case, I'm going to do gear minus minus. So let's go into Unity. There may be something not working here, but we'll find out soon enough. So wait for the script to reload. And now I'm going to select my car, apply the car controller script to it, and let's start setting up our variables. So our wheel colliders front, I'm going to have a couple of these, and here they are, front right, front left. Okay, this is set. Now for the rear, we're going to have rear right and rear left. Okay, rear left. My engine sound is my audio source. Okay. Now the motor power is going to be 250. Again, I played around with these values. You can do the same. The brake torque is going to be 3,000. Center mass 0.200. And they're going to have 6 gears. And our gear ratio is going to be, well, for 0, 0, for 1, 3.794. Then 2.324. 1.624, 1.24, and 1. Max speed, let's set it to 500. The brake lights, let's add my 2 brake lights here. Right and left. And let's start with automatic gear, just to see if everything is working correctly. So I'm going to press play. And yeah, we seem to be able to drive our car. Look at that. Unfortunately, we'll still need to set up our camera, which we're going to do right now. So for the camera, I'm going to create a... Oh, we need to import. So let's go to our package manager and import Cinemachine into our project. My assets, Unity registry, Cinemachine. Why am I not allowed to? My game's not running. Interesting. Okay, I'm going to pause the video right now And when I come back, we'll have Cinemachine imported, and I also gonna start recording the audio of my system so you can hear the engine revving. And we're back, and we'll start by setting up my Cinemachine camera. What I'm gonna do is, first of all, I'm gonna split the scene so I can see what's going on in my game view as I adjust the camera. Set it up to 16:9, and let's work with the top rig, middle rig, and bottom rig. I'm gonna start by I need to adjust the y-axis value. That's just for view. I'm going to adjust my my middle rig. I'm going to start by increasing the radius so I can see the car from afar. Increase the height a little bit. And adjust the default x-axis value to 0. Now adjust the height and increase the radius a little bit more. And more radius. I think that's good. Yeah, I think that's okay. And I don't want to change this view as I potentially move the mouse. So I'm just going to adjust the height to be the same on my top rig. There you go. And my bottom rig. And the radius, I want it to be the same as well on all three. And I think that looks good, I believe. Let's just double check. I think I've disabled the screeches for now because we're not handling the screeches, and I want you to be able to listen to the sound of the engine. So I'm gonna press play, and let's see how it goes. And we can drive the car, and we can hear the engine. It's pretty good. It seems to be working fine. You can hear that the engine revs up and down and is shifting gears as I accelerate and brake. Okay, that's a very, very promising start. That's good. That's good. And the controls are pretty responsive. You can notice that our tire radius changes, and on top of that, our braking lights are working beautifully. Great. So in the next video, we will work on the space bar and the drift logic.